Hi there, this is GCSE Physics. This is Energy Lesson 2, Efficiency. So we're going to utilise the efficiency equation and solve some calculations and to identify how to improve efficiency. Okay, let's make a start. So first of all, we need to know what useful and wasted energy are. Useful energy is energy transferred to where it is required in the form that it is wanted. And then all other forms of energy referred to as wasted. Wasted energy then spreads out into the surroundings. It's usually in the form of heat energy, causing the energy changing device and its surroundings to become warmer. It is very difficult to concentrate this energy again and make use of it, which is why we call it wasted energy. Because it is essentially, most of the time, unusable. Okay, let's move on. Oh, before we do the spreads out, we can you'll also see a word called dissipate. So it spreads out into the surroundings or dissipates into the surroundings. So energy efficiency. Energy efficiency is a measure of how usefully energy is converted by a device and is given by the equation efficiency is equal to useful energy output divided by total energy input. There's no unit because obviously useful energy is measured in joules, for example, divided by total energy input in joules, and they cancel out to give just a number. So efficiency doesn't have a unit, it's given as a decimal and also as a percentage. So as the useful energy output can never be greater than the energy input, the efficiency can never be greater than 1 or 100%. Just a bit of extra information before we do some calculations. Energy efficient light bulbs, so these come up quite a lot in examinations. These produce, compared to the old style halogen light bulbs, these produce more useful light energy for the same amount of electrical input energy. So they waste less energy as heat. So in essence, they use less electricity and less energy. So they're cheaper to run. So the equation, efficiency is useful divided by total. Clean my box up, there we go. What I'm going to do is to show you how to rearrange it. So if you want the useful energy, we need to get rid of the divide by total, and the only way to get rid of divide by total is to times by total. So efficiency multiplied by the total input energy would give us the useful. And then to get the total, as you can see, we need to get rid of a times efficiency, so the total would be equal to the useful divided by the efficiency as a decimal, not a percentage. So there's the three versions of the equation. As you can see, that's an excellent rectangle. There we go. Or quadrilateral. One more tip I'll give you. If you remember the equation in this format, efficiency is useful divided by total, and you need to find total, and you're not too sure mathematically what to do, you can remember just to swap these two around. So you just get the total is the useful divided by the efficiency. Okay, if efficiency is given as a percentage, please convert it into a decimal by dividing by 100. Let's do some calculations then. Here's one I made earlier. If you want to pause this and have a go at it, and then I'll take you through the answer. So calculate the efficiency of an electric motor if it produces 84 joules of useful kinetic energy when supplied with 80 joules of electrical energy. So the efficiency is equal to the useful divided by the total. So really straightforward. So useful is 48 joules divided by the total of 80. And that gives us 0.6. If you're at 60%, that's fine. Just times it by 100. Let's try another example. So if you want to pause and have a go at this one. Calculate the useful light output of a light bulb with efficiency 0.2 when it's supplied with 400 joules of electrical energy. So efficiency is useful divided by total. And in this one, we need to find the useful. So to get useful, we can get rid of the divide by total. So we get efficiency, and the way to get rid of a divide by total is to times by total. So that'll give us the useful energy. So efficiency is 0.2 multiplied by the total of 400. So 0.2 times 400 gives us 80 joules of energy. Okay, let's do one more. So another relatively straightforward one. If you want to pause and have a go, calculate the percentage efficiency, so it wants in a percentage now, of a light bulb if it produces 30 joules of light when supplied with 240 joules of electrical energy. So the efficiency is equal to the useful divided by the total. Really straightforward. So the useful is 30 joules of light divided by a total 240 joules of total electrical energy. So 30 divided by 240 gives us 0.125. And then we just need to times it by 100 to get it as a percentage from a decimal. So that will be 12.5% efficient. Okay, I've got some more questions. So if you want to pause and have a go at this table, try and figure out what's missing and how to do it. Then I'll take you through the answers. So the first one. So we've got input energy of 100 joules, useful is 40, so the wasted energy must be 60. So then efficiency, remember efficiency is useful divided by total, so 40 divided by 100 give us 0.4, and then times by 100 to get a percentage efficiency of 40%. So the next one, the input energy is 250, wasted is 50, so the useful must be 200. So efficiency is useful divided by the total input, so that's 200 divided by 250, which gives us 0.8. And as a percentage, that's 80% efficient. Next one, so we've got an efficiency of 0.2 and the input energy is 50. So we need to get useful energy. So I'm just going to jot this down just to show you. So efficiency is useful over total. Useful over total. So we need to do times by total. So it's efficiency times total, as you can see hopefully there. So efficiency times total. So we've got 0.2 times the total input energy of 50, which gives us 10 joules. Wasted, we need to do the total input 50 minus the useful energy. So 50 minus 10 gives us 40. And if the efficiency is 0.2, then the percentage is obviously 20%. So the next one, if the percentage efficiency is 30, that means the efficiency must be 0.3. If the input energy is 80, we need to do the same as what we did last time and do 80 multiplied by the efficiency of 0.3, and 80 times 0.3 gives us a useful energy of 24 joules. The wasted energy can then be found by doing the total input of 80 and subtract the 24 useful to give us 56 joules of wasted energy. Last one, 60 joules are useful and 60 joules are wasted, so that gives a total input energy of 120. So efficiency is useful over total, so 60 divided by 120 gives us an efficiency of 0.5, and as a percentage times by 100, that's just 50%. So one last thing, how do we improve efficiency? So there's a couple of ways that we do this, which you need to be aware of. Pretty straightforward. We need to decrease loss to heat by reducing friction by using a lubricant, for example oil. Lubricant is the one that's normally on exam mark schemes. Reducing electrical resistance in electrical circuits, that's another way. Another one is reducing air resistance by using streamlined shapes, or reducing drag by using streamlined shapes. And we could reduce loss to sound by tightening the loose parts of machinery, which, maybe not the greatest way of improving efficiency, but every little helps. Anyway, thanks for listening to that. I hope you enjoyed it and I hope you found something out that was useful. Hey. Yeah, that were a bad joke, bad physics joke. Anyway, thanks for watching and I'll speak to you soon.